Okay, so we are on, oh, I don't even know what week we're on. I think we're in 8, 9? We are in 9. We're in week 9, day 1. So this week we are deciding to do a review week of some of the concepts we have learned throughout our earlier modules. And today we are going to be looking at higher order functions in JavaScript and Python, and then also looking a little bit at lambdas and list comprehension as well in Python. So everything we're doing today, and I said this earlier before I started recording, but everything we are doing today, you can solve by just doing a loop through an array or a list or whatever. All these can be solved that way, absolutely. However, we loops are more, so there are two types of like programming paradigms that we've talked about quite a bit in the beginning of this course. There's like imperative coding, which is more telling step by step by step exactly how you want the computer to behave. And then there's also declarative coding, which is telling the computer or explaining how you want the output and letting the computer do most of the stuff for you without telling it exactly, if that makes sense. So when we're solving these problems with a for loop and doing our I plus plus, let I equals whatever, I is less than the length of the array and I plus plus, that's a very imperative approach. It's a very mechanical approach to solving the problem. Nothing wrong with it, but it's just very step by step by step. Higher order functions let us give what our intent is for the problem. So instead of saying it step by step by step, we're going to give the intent of the solution, and these higher order functions let that just happen without quite as much code. So a couple of takeaways that we'll see throughout this is if you are doing a lot of I++ and push to like a different array, or of course in Python it would be append, you're probably working too hard. There's probably a higher order function that you can use while iterating through this, whatever iterable you're working on, to get that information in a new array to work with. So we are going to look at all these different higher order functions. There's 4 of them we will be looking at in JavaScript, which equates to pretty much just 2 or 3 in Python. But we're going to look at these with an example problem that we will try to solve at the end, given what we're learning with these higher order functions. So given a list of numbers, we want to keep only the even numbers, and then we want to double them, and then we want to sum the result of those numbers. So we can absolutely solve this with a regular for loop, right? Let's just make an array first. That would be our numbers. And let's have it be 1, 2, 3, 4, 5, and 6. Okay. So we can start with maybe let sum equal 0. And we can do 4. We got to do our let I equals, 0. And I plus plus. No, I is less than, we got to do the length first. I is less than the length of numbers. And then I plus plus for iterating through. Okay, so this is just our regular for loop. We're going to iterate through this. We want to keep only the evens. So we have to grab the value, which would be if, let's do numbers, if that index, that the value of that index we're on is modulo, what is this? Does anybody remember what this is?
The modulus, you mean?
Yeah, what does that do?
Checks if it's even.
Yeah, it checks if there's a remainder, right?
Yes, exactly. Checks if there's a remainder. So if we're dividing by 2 and the remainder is equal to 0, we know that's going to be an even number. So We're checking each value in this array and saying if it's even, if it's divisible by 2. Then we're going to add it to, we're going to double it and add it to this sum. So let's start a running total here with our sum. And we're going to take that nums I and multiply it by 2. Right? So let's do a console log here and see if this works. Console log sum. So this isn't like a function. This is just, we can put this in a function, right? And run it as a function. But this is a way to solve this if we have this list of numbers, how we would iterate through and double or keep the even numbers and then double them and keep a running sum. So let's go ahead and node example. Oh, geez. And we can see that gives us 24 by doubling 2, 4, and 6 and adding them all together. Cool. So this is totally acceptable. This is I mean, it works. So if it works, it's okay to use this method. But there is definitely an easier way to do this. And there's lots of places in this to have some mistakes, right? Like we could maybe not select the right thing here. We can maybe just, if we accidentally put I modulo 2, which would be like the index, right? So that wouldn't work. We could do some small things here and there to mess this up. So there's definitely a better way to go about this. So higher order functions, does anybody know what a higher order function is? Like what makes something a higher order function in JavaScript or Python?
Is it that it calls another function?
Yes, yep. So it'll either take in or call another function, or it will return a function. So if either of those two conditions are met, it's considered a higher order function. So there are 4 different higher order functions in JavaScript. Does anybody by chance know what those 4 are? If you don't, that's fine because we're going to learn them, but I want to see if anybody maybe has heard of anything. We have sum, yes, sum of a list. Okay, so that is a Python one, right? That's a built-in higher order function with Python. And then I see map. Yep, map is definitely a higher order function that exists in both JavaScript and Python. I don't know what the candy cane. Those are not, but good guess there. So sum is in Python, it's its own built-in Python method. In JavaScript, it's called reduce, is what we would use to do like a sum. It's using kind of a reduce function, which is one of our JavaScript higher order functions. Map is another higher order function for sure. The easiest we're going to start with JavaScript is simply we want to do something for each item in this array. And we're just going to do something for each element. That's it. We're not going to return anything of meaningful value. We're not going to make a new array and return that. We're just going to do something for each of these numbers. So for that, we would use, let's see, a for each. For each is the first higher order function we will learn in JavaScript. It's not used a ton because it produces just side effects. And when I say produces side effects, what does that mean? What's an example of a side effect?
You mean like an unintended outcome?
Well, I intend for it to happen. I'll write it in the code. But it's not a value being returned at the end of the function. It's There's no return statement. So like console log, that's an example of a side effect. You can't return a console log. It just prints on the screen, right? You can return an F string, but it's not really, you don't save that in it's not a value saved that you could carry on to use in other functions. So it's called a side effect because it just throws up on the screen and it's not really useful in anything else, just for this purpose, what we're using it for. So usually you see it in logging or like notifications where it's like for each of these things. Like we're just going to take an array, this numbers array, and we're just going to print up on the screen. Let's say this was error messages in here. Something was keeping track of all sorts of error message. We just want to print each message on the screen as it comes up or as it's held in this an array. So how we can do that is we will take this numbers and we will apply this function, this method on the array. And we can see as we do our for each, it takes a value, an index, and an array, and then returns function that accepts up to 3 arguments, performs the specified action for each element in the array. So it returns this void. So it doesn't really return anything. But we just want to print each of these numbers on the screen. So we're going to use an arrow function here for each, because for each needs, in order to be a higher order function, it's going to take in a function and do something for each of these items in the array. So our function that we are passing in is going to be a fat arrow function, and it's going to take each number that we're on in the array. We're just going to console log. We'll say saw, I guess, and then the number. Okay, so this will just iterate through. It's going to go through. It does the iteration for us. It's doing this let I equals 0. I is the length of this array. Because what if we don't know the length of this or where we want to stop in this array? We just want to go through. It takes out all of this and replaces with just a simple for each. So this is iterating through each element of the array, and this is the function that it's taking in and applying to each element in the array. So with a fat arrow function, right, this is the argument or the parameter we're passing in. And then this is the expression or the function we are applying to that argument, right? So we're going, each number, we're going to console log. See if it works. We can see, we saw number 1, 2, 3, 4, 5, 6. So it's just creating a side effect. It's not returning any values that I can grab and use in another function, but this is an easy way to iterate through this array and do something to each of these. Usually, like I said, for each, you'll just see console log. If we want to make it, let's see, a little cleaner, instead of this, oh, no, we're not gonna make it cleaner. We'll come over and do the Python. So each of these examples, I'm gonna show you the Python syntax as well, real quick. But we're not gonna spend too much time on the Python ones, and we'll see towards the end of the class why. But in Python, there is no for each equivalent, really. It's just a regular for loop, because the for loop in Python already has for number in, like if we had a list of numbers. We can just say for each number in nums, let's print and saw. So this is easy enough, right? We don't need to make this any simpler in Python. JavaScript, we have all this, let I equal 0, all this extra. So that's why they have this for each to help make it a little bit easier. But in Python, this is like super easy. We don't need to make this any simpler than it already is. So a for each in Python is just going to be a regular for loop. Any questions on the for each? Again, you won't use this much besides just doing console logs or logging, really.
I can't remember anything about arrow functions. Is there like a quick primer?
Yeah. Okay, so we're going to be going into arrow functions a little bit later with the lambdas, but I'll go ahead and roughly show it right here. So typically with a arrow function, you'll define like constant function. Oh, let's do this example function equals x is the parameter being passed in, and then you do a fat arrow. And then, oh gosh, fat arrow. And then this is the expression you would apply to x. So like x times 2. But an arrow function will have its name first, the equals, and then usually you see the parameters being passed in here. They can be in parentheses like we saw here, and then the arrow, and then the expression that you will apply to it right afterwards. If it's just one line, you don't need to add the curly brackets. You can just have it as is. But this one we did multi-line, so we wrapped it within the curly brackets. Because thankfully fat arrow functions, you can do a whole, expression, multi-line expression, and a whole bunch of work down here underneath it, and do whatever you want. We'll learn with lambdas, they're not as nice as fat arrow functions. But does this make sense? So if we had, let's see, trying to think of a really easy function we can convert. Any function you see can be converted to fat arrow. You just put an equal sign between the name and the parameter being passed in, and then draw an arrow and do your curly brackets, put everything else in between. Does that make sense?
Yeah, yep, easy enough.
Okay. And we'll see fat arrow functions a few times here because it's easier to write them in one line and some of the things we're going to be doing. Okay, so for each, that's all we're going to look at for that. They just do side effects. Don't really return anything new. But we want to return something new at the end, right? We want to have first, we want to keep only even numbers, and then we want to double them. And then we want to sum the results. So this sounds like we need to actually like keep items from this array and carry it through to be able to do things with them later. So next we're going to be looking at map, which was brought up. And map is a concept that will transform every item in the array. So for each did something to every item, but map is going to transform every item in the array. And it returns a new collection, so a new array with those transformations. There are no side effects usually from map. You will get an array returned from map that is just manipulated in the way you want it to. So let's take this constant numbers, and now the best way to show this is to do the double them. Let's say we want to double every single number in this array, right? So we can do that with, we call this double. I'm making this a fat arrow function. So it's going to take in a number. And we are going to fat arrow over, and we're just going to n times 2. Okay, so I wrote this double function because higher order functions need to take in a function or return a function. But most of the ones we're looking at are going to be taking in a function as one of the arguments for our higher order function. So I have this double function that when given a number, it will double it. Okay, I want to do this function to every item in this array. So that's where I can use map. I would take that well, let's go ahead and make a variable to save this into. Doubled numbers will be equal to our numbers array. We're going to map with the function. So when we see map takes in a callback function, so it accepts up to 3 arguments. Usually you just pass in a function that will be applied to each item in this array. And then it will return an array that contains those results. So we want to double every number. We want to apply this double function that I just wrote to every item. So we're just going to pass in our double function that we defined up above. So now the doubled should have an array returned that's each one of these numbers just doubled. So that's what we told it to do. Okay. And everything else is commented out. And we can see it did indeed go through and apply this function that we created to every item in this array. I suppose I should make notes on here. So this is going to be map, and this is transform every item in the, or every element, I guess we could say. For each is here, that would do something for every element. Okay. So any questions on map right now? Map will take in a function that is applied to every item in an array. So it's useful to transform everything in the array. So if we wanted to double everything, if we wanted to, I'm trying to think of more examples. I can't think of any right now. I can find some in a bit. But you can do map with more than just numbers, right? You can remove all letters. Like if you have a whole bunch of strings, that's a mixture of letters and numbers, a whole bunch of items or elements in an array that are all varying. Trying to illustrate what I'm talking about. Like if we have stuff like this, you can make a function to remove numbers from each of these elements in this array, and then just keep the letters. And so then your return would be like SLDHA, so you can do things with strings as well. You can make this function that you apply to each element whatever you want. So this can be helpful if you want to like remove white space at the beginning or end of something. If you have like a list of or an array of strings that maybe might have white space, you could just apply something that removes white space to everything in that list. Python, I keep switching back to Python. Okay, so let's see real quick how that works in Python. So we're going to say, again, we're imagining we're taking the same numbers. I guess we can put it here. Doubled is going to equal. So in Python, the map function does not return a list. It returns like, forget what it returns. Let's see. It returns a map object. So that's not useful for us most of the time. Most of the time you want just a new list with those items in it with the function applied to it. So in order to transform this into a usable list, we just simply put, change it into a list here. Mutable. We go ahead and change it to a list. So, but it also takes in a function. So now we are going to see our first lambda. So this here, I could have thrown within this map. I could have just thrown the fat arrow function within here, which is kind of what we're going to be doing with this lambda. So lambda, and we will take a look at this in just a second. And times 2. Okay, so at first glance, does this look similar or not to how our fat arrow function is written? It looks pretty dang close, right? It's kind of structured the same. Of course, this has this weird word lambda, but we could see, if we hover over this, a parameter, and then colon n times 2. Down here, we had a parameter, and then a fat arrow, n times 2. So lambda in Python is going to be set up pretty much the same way as the fat arrow function is in JavaScript. However, lambdas can only be one line. You cannot have multi-line lambdas. So if you have a lot of things you need to do in this expression to this parameter, a lambda is not going to cut it out. Whereas with a fat arrow function, you can have multi-line, right? We just looked at that. But it is how you make a lambda is you signal its lambda. Typically you have, if you want to give it, let's see, item. So here we named the function right here. We do constant and then the function name equals this. Here we can have the function name or whatever's holding the value. It doesn't have a name, really. You don't name lambda functions, but you do have something that's going to hold the value. So you can throw it out in the front, equals, and then lambda is the flag that we're going to do our fat arrow in Python, parameter, colon, and then the expression that you apply to it. Very brief overview with lambdas because there are better ways to do some of the things we're looking at here. And we'll look into that towards the end. Spoiler, it's using list comprehension. You will use that more often than lambdas. However, lambdas really shine in sorting. So I have a example problem here. Let's say we have this pair of, what are these?
Tuples?
Yes, tuples. Okay, so tuples, kind of not super used often, but good to know. We have this list of tuples. If we want to sort this list of tuples, kind of hard to do, right? Like, let's say we wanted to sort on the letter versus the number. We could sort, and it would probably, I think, grab the first element in this, but we want to sort on the letters. So this is where we can use a lambda, because we say, okay, sort on this key, which is going to be iterate through this iterable, this list, and take this pair, and then just select the one in index 1. And then it will print the pairs. Let's see. Forget how I call my Python. I should be just Python. So we can see then it did successfully grab that second item in the tuple and sorted based on those values versus on the numbers that appeared first in the tuple. But sorting is a very good way to use a lambda. It allows you to grab specific values versus just, especially with the sort, because it's going to sort in place. Let's see, apply it to each list item and sort it, ascending or descending. But this gives you a little more control over what it's sorting on, if that makes sense. But that's just a very brief look at lambdas because, again, we're going to be probably using list comprehension more than we use lambdas. And we will spend a little bit more time with those towards the end. So that was map. Any question on map? What we're doing with map? Okay, so for each, we are doing something for every element. Map, we are transforming every element and returning a new array. All right, the next one that I did not hear called out or see called out, but now we're going to look at filter. So filter is exactly how it sounds. We are going to keep only what passes a test. So again, higher order functions need to usually take in a function to operate. With filter, we are going to pass in, it's called a predicate. It's going to be a function that's written to return a Boolean. We basically want to ask a yes/no question, and it's going to apply that to each item in the array. And if it passes that yes/no question, it will return that in the new array. Okay, so a good way to do that is, look, keep only evens. That's one of the things we want to do for our final problem. So easy, keep only evens. Let's write a test that would determine if a number is even. So let's have our array here. Okay, so we're gonna say is even. This is gonna be our function that's going to determine if a number is even. It's gonna take in a number, and then it is going to go ahead and figure out if this n modulo 2 is equal to 0. Okay, so this function would return a Boolean, right? Because if this is true, if n modulo 2 equals to 0, this would evaluate out to truth, or true, a truthy, right? But if it's not 0, then it will evaluate out to false. So this function is a true or false Boolean response. This is what we can apply to each item in this array to test it, see if it passes that test. And we do that with our filter. So evens equals nums filter is even. Okay, so once again, here's the higher order function, which is taking in this function we wrote here, and it's evaluating each element in this array, and it's going to only keep elements that evaluate out to true. So then we should see console log here. And this transforms the original array. So it doesn't change anything in this array. It doesn't change the elements, and it doesn't produce a new array. It simply keeps a subset of this array. If that makes sense. So let's call that, and we can see it does 2, 4, 6. At least that's the way I remember. Let's look at our README, because I feel that is right, but I don't want to misspeak. It's very important to know if it returns a new array or not. Let's see. So I'm looking at our README for today, which I'm not 100% following. I guess it says creates a new array. Okay. Let's Google, because that's not very clear. Did somebody else should do one because the index values change? Okay, yeah. Yeah, as I was saying that, I'm like, this doesn't sound right. This doesn't sound right as I'm saying it. I don't see how it could be the same array. So that absolutely makes sense. We will just, this is filter. Yes, uses a method to create a new array. All right, gotta love Googling when I don't 100% know. When we are learning all this, these higher order functions, try to understand the concepts, but the syntax will change. And these concepts exist in every programming language you'll work in. There will be some sort of higher order function you can use, no matter what language you're working in. So of course we're learning in JavaScript and Python, but if you go into C#, there will be an equivalent for C#. Just try to understand that there are these type of transformative higher order functions we can do in place of a regular for loop. And that is the goal of the end of this lesson. Okay, so filter, we've determined and turns new array. Keep only what passes the test and keeps and returns the new array. So here's our new array. In, let's see, in Python, we also have a filter. But just like map, it does not return a list. It returns an iterable object or well, let's see what it returns, what it's called again. This was called something different, but it returns an object. So we are doing filter. I'm not in doing evens. It's a list. Well, let's just do filter first and see what it returns. Yeah, iterator, a filter object, an iterable object. So just like what I said. So we're going to have to change this into a list instead of an iterable object. But filter will take in a function to apply and evaluate each item in the array. We would do that with a lambda here. So we're going to take a number and say if that number modulo 2 is equal to 0. The other thing it also takes in is the function and an iterable. So you have to, unlike JavaScript here, well, no, we did it right there, but we have to pass in the, we should have passed it in here too. Actually, I'm sorry. We have to pass it in there as well. We have to pass in the list that we are not there outside of the lambdas that we were going to evaluate this against. We don't have a nums though, so let me put that up here. Okay, there we go. Looks better. Nobody called me out on this, but that's okay. So of course, in JavaScript, we do the array dot, and we do a lot of the dot methods. In Python, we are calling this method, and then we got passed in the iterable item into this method. So again, this lambda function looks very similar to our isEven function here. If we want to write this in one line, let's do that here. Yes, we'll call this inline. And then we're going to pass in, and we're just going to give the fat arrow function in here. Okay. So this is how we can do it all in one line, right? We don't have to define this isEven function outside of it. We can just write it within the filter method. Not like not spaced out. Okay. Any question on filter? So you'll write a function that's returns a Boolean, either true or false, and it will evaluate each item in the array or list and only keep those that meet the condition. All right, last one. So V said sum, favorite one in Python, because it makes it easy to just add every item in that list. So in JavaScript, we're going to use something called reduce, which is turn many values into one. So just like it sounds, we're going to reduce a ton of values in, or a ton of items in this array into just one value returned. So we're not going to, yeah, anything to avoid writing out a whole loop for sure. We don't want to do a for loop to do sum equal, like we were doing up here. We were accumulating right here, right? That sum plus equals. We were accumulating in an, like, in a, oh my gosh, it's late at night. Variable outside of our for loop. So reduce is going to do this for us. It's going to accumulate the value. But it's weird. It's weird how we work with reduce. So it still takes in a function to apply to an array. However, this function rewrite has to have an accumulator and a current value. So we're just going to look at, let's see, I'm just going to copy this over and we're going to look at this together. Okay, so here's our number list, right? This here is the function we are going to pass in. And we can see it takes two parameters. It takes an accumulator, we've shortened it with acc, whatever, and a number, which is going to be the current value. And then it's going to return the accumulated value plus that number. Because that's how we're going to add things together, right? That's how we do it up here. We have our accumulator, which is this variable we defined up above, and we're going to add in that current value. So this function that we write to reduce has to take in that accumulated value that we're going to add the current value onto. So this is pretty much going to be a constant. You can do different things instead of like adding that number. You could multiply by it. Like if you wanted to do, what is that, factorial? You can then multiply by n. You can do different things for the accumulation, but you need to pass in the accumulator and the value you're manipulating at that time with it. So now we can see our total is going to take the numbers array and then use the reduce method. And we're going to pass in the function sum, which we've established up here. So it's going to use this function on every item of the array. And then it also passed in a 0. What is this? What do we think this means? Let's look at our hover over here. So let's see what it takes in. It takes in a callback function, which has a previous value and a current value. And then it also takes current index. So this 0 that we're passing in is not needed, but it is helpful to avoid edge cases sometimes, to identify where you're starting in your, like if you don't pass this in, you're going to start at the beginning of your array and just iterate through and apply this reduce to everything in the array. However, we can start it halfway through the array. We can choose like a start at index 3 instead and reduce from then on. This is just explicitly telling where to start accumulating those values. And it makes it just, it's, yeah, very explicit intent here of where we want to start accumulating. Okay, so reduce always takes in a function that has two parameters, the accumulated and the current value, and does something to those items. Any question on reduce? It can be a little abstract. But this is, I mean, you can reuse this for sum, for multiplication. Of course, we would change that to just multiply if we want to multiply all the values together. there are other very interesting ways you can use reduce, but we won't go into that now. Let's see, in Python, also kind of weird to use reduce. It's not like we have to import we have to import a different module. It's not just standard in Python. We have to import it. So we would have to do an from functools import reduce. Super weird. But then once we get it imported, it's pretty much the same. It's going to reduce, we're calling the method, it's going to take in a function, which is going to be a lambda in this case, and it's going to take in two parameters in our function that we're passing in, the accumulated value and the current value. And then it's going to do something with those two parameters. So we're going to add the current value to the accumulated for adding these all together. And of course, we got to identify what list we're passing in. So it would be nums if we had it here. And then we can also, just like in JavaScript, identify the initial value or the initial location we're starting at in our list. Okay, so same thing, taking in the same two parameter function and doing something with that accumulated value and the new value. So when we hit this first one, what is the accumulated going to be?
One.
Going to be 1. I actually don't know. I think it's 0, but I need to look at this. Let's Google it. I'm simply just Googling what is accumulated value at the beginning. I think it says it in our README. Actually, no, it doesn't. Okay. So this isn't the initial location. This is the initial value. Okay. No, that says current index. Is that part of that's part of the callback function though. Ugh, I hate these. Okay. So if you see array reduce, it has callback function, and within that parenthesis of the callback function, you'll have previous current value, current index. So that's where I was getting confused. You can pass in this the index as well. And then it also has an initial value as well. It's the initial value used to start the accumulation. Okay. See, that's why it was 0 for me, because I identified it as being 0 when we started. So when we pass this in, that is going to be what we start accumulating at. So the accumulator is going to be 0 right off the bat, and then n is going to be 1. So then it will take 0 plus 1 and return that. So now we'll have 1 as our accumulated value that will be passed in to reduce. And it'll keep working its way like that. Okay, any questions on reduce? Okay, so now we're going to put this all together and solve this given a list of numbers, keep only evens, double them, and then sum the result. So let's get our numbers back down here. Okay, so how do I keep only evens? What higher order function can I use to keep only evens?
Filter.
Filter. Yep. So we're going to say our result is numbers. And then we're going to do, I'm going to enter down because I'm going to string together methods. Like in JavaScript, we can string together methods, right? We can do a filter and then we can dot something else onto it and then we can dot something else. So for readability, I'm going to enter down so we can work on this one at a time. Okay, so we're going to filter and this takes in our function, which we'll use to be evaluated against every element in the array. Which we did up here. We can already see, I'm going to use just this right here, right? We did our evaluating if module 2 equals 0. So let's filter and evaluate on this expression and only keep evens. So now, after we did that, what's the next one? I'm going to bring this down here so we don't have to keep scrolling up. Okay, so we kept only evens. Now let's double them. How do I double every element in the array? What's higher order function should I use for that? Did you say map?
Yep.
Yeah, I cut out, but yeah, exactly. Map applies something and transforms each element in the array, right? So we're going to map over each item and we're going to pass in a function that doubles them, which we did above, right? We did double these numbers. So let's take that. Okay, so now we have that times 2. So we've kept only evens, we doubled them. Now we need to sum the result. What higher order function is that? We just covered it.
Reduce.
Reduce, yes. So this is summing the results. And as V said, there is, instead of doing reduce, if we are summing the results, you can literally just sum. It is doing the same thing as doing this reduce, accumulating, adding them together. But okay, so we're going to reduce. Reduce takes the, let's see. So in our fat arrow function, it's going to take an accumulator and the current value. And then it's going to do this fat arrow function. It's going to do the accumulator plus that value. And then we're going to start at 0 as our initial accumulated value. Okay, so that's kind of what we did here. Sum is equal to that. So we just plugged it in, right? Within inline. Okay, so now we've got our keep only evens with filter. We're doubling them and then we are reducing them to add the result together. So now we can console log our result. And we can see it did in fact give us 24 in a little bit more readable of a way than doing this iteration through that we did before with our for loop. But it works just fine to do this. This worked just fine. However, it's kind of nice and easy to read. The goal of higher order functions and one-liners like this with lambdas and fat arrow functions is more for clarity and readability and not so much like being clever and trying to be a cooler programmer by having like these fancy little nifty one-liners. If you have a whole bunch of, if you're passing in like a fat arrow function that you have to explain a lot, probably not a good idea then to do a one-liner like this. I would probably break it apart. And for lambdas, definitely, if you have to explain a lambda, it's not very easily readable, don't use it. Yeah, that's my 2 cents. You're going to be writing code that someday a junior developer will come in behind you and look at, and if they can't understand what you wrote, then I mean, it's a huge issue. I mean, yes, the junior developer can dig in and learn how to read it, but also you can just make it a little bit more readable yourself. Okay, so that was doing that problem in JavaScript. Now let's put it together in Python, which I am just going to copy and paste. So we can move on to why we're not going to use these functions in Python. And we have an easier way to do this. Okay, so in Python, we have our result equals reduce all of this, and we're just kind of nesting our functions together. So we're reduce, and here's our reduce function that we're passing in with the accumulator. And then we're also passing into this reduce the map and filter. Like, this is getting a little bit difficult to follow, right? We can do this, but it's kind of hard to read. Don't even know what's going on, being called where. You can step through it and learn it. So we can do this, but we don't want to. There is a much easier way to do this than using these higher order functions, and that is through something called list comprehension. So this is Python's preferred way to do declarative programming. So declarative is what we've been doing, where we're telling where we want to end up versus imperatively writing out every single detail of how we want it to go through this loop. Okay, so Python's declarative approach is using list comprehension. So let's take this list of numbers again that we have. And I'm going to pull up a visual here because we have a really nice visual in the curriculum to show list comprehension. So in Python, the general structure syntax for list comprehension is pass in an expression or function for each item in an iterable. Pretty easy, right? Do something for item in iterable. So it would be for element in list or for letter in string. You know, that's pretty straightforward. Can be any expression, and it's evaluated once for each item. So kind of like our filter, like all of our higher order functions in Python, right? They iterate through and evaluate each item in the array, element in the array. So the same thing with list comprehension in Python. And it's going to evaluate for each item from the iterable in that iterable object. It could be a list, tuple, etc. So this is a very nice illustration of list comprehension. Okay, so if we want to start with, let's start easy and just, let's see, what's the, let me get back the little problem here so we can look at it. Oh, of course, it's not the same. I know the shortcut, but I'm not doing it because I'm lazy. Okay, so given a list of numbers, we want to keep only evens, double them, and sum the result. So let's start with something first that we can apply to every element in this list, every item in this list. We're going to double everything, okay? So with our list comprehension, we want to double each number in this list. So how we can write that is we'll say our doubled list is going to be, let's take, and we have to put it in square brackets, okay? I don't know if you caught that in our little image here, but it has square brackets around this expression or this list comprehension. So I have my square brackets. I want to double the item, like number times 2 for the number in our numbers list. Okay, so the item or the element in your list is what you will use as the variable that you will apply your expression to. Okay, so here I'm saying number times 2, so do this for every number in this numbers list. Okay, so now if we print doubled, we will see it went ahead and did that for each item in this list. So easy, right? We didn't have to use map. This is doing the same thing as map, but we're using list comprehension instead. Much more readable and definitely will be easier for doing other higher order functions on these on this list. Okay, so we got this doubled. Now we want to keep only the evens. So we can add on the end of this expression here, on the end of our list comprehension, we can add a condition to this. So we can say, do this for each number in the numbers. If we can add an if statement at the end here, if the n modulo 2 is equal to 0. Okay, so we have an expression to apply for each element in this list. And then we can say if and add an if statement at the end here to go ahead and filter out what we don't want to do this on. So this is going to double everything in only if it meets this condition. So now when we print doubled, we can see it's going to, and it returns a new list when it does this. It's going to only return those that meet this condition and apply this expression to the ones that meet that condition. So we can see now only the even ones, 2, 4, and 6, all got doubled here. So easy enough, right? We don't have to do our filter on this with our lambda here. We can just add this on the end of our list comprehension in an if statement. I wonder if we have another image here in our README. Which, if you all want more in depth for the lambdas, go ahead and you can look at this day 4 for week 2. That's where it has all this. But again, definitely use list comprehension more. I don't think it has, no, it doesn't have the additional thing on our, but we can see here it does that down here, adds the if statement on the end of our expression here, our list comprehension. Okay, so we've done the first two. Now the last thing we need to do is sum the result, which V has shown us it's really easy to do that. We'll just go ahead and let's do sum equals sum of doubled. And we can see it gave us 24. So sum is our built-in reduce for adding them all together. And there are other built-in Python functions that we can call to do reduce type. There's all those, the math tools. You could do like factorial and stuff like that with some of the math tools in Python. That's something for you to look at on your own. So final takeaways here is just learn each of these higher order functions and what they do generally. The JavaScript ones will be really helpful for you when we get to React. For Python, if you want to do higher order functions, instead of writing a for loop, then try to steer towards the list comprehension instead. Definitely more readable and easier to use. Any questions on anything I went through today? Sweet, that was only an hour. I tried to keep it quick. Yeah, I don't know who thought it was a good idea to take this out of the curriculum. Like, these are very helpful and important, especially with solving some of the algorithms y'all solved. These methods, and they can definitely go a lot further than a lot of the for loops you were beating your head on. But all this is in our, like I said, I linked it in the calendar just to go to week 2. So you should come up on this screen, but it's these 3 here, these lessons. So you have the JavaScript, the Python, and the Lambdas and list comprehension. Any other questions before I stop recording? And I'll show you what exercises I'll have you do today. Oh, okay. Let me stop recording.